So today we're going to be meeting the toolkit. So we're going to be seeing kind of the different pieces that we're going to be using throughout the semester, in particular R and RStudio. So I want to just start with an agenda here. So I'm going to begin by going through that penguin study that you all worked on for the application exercise. So I'm going to go through that, and in doing so I'm going to demo a couple different things in RStudio Pro. And then I'm going to go kind of slowly through R and RStudio and then R Markdown. Okay, so let's start with the penguin study. So I'm going to pull up my RStudio Server Pro instance. And I've already started it here, but I'm going to pretend like I haven't. So I'm going to go ahead and open this and just create a new project from scratch. And so this process is exactly what you're going to be doing for labs in the future. This very first one, I had created the project for you and uploaded it to RStudio Pro. But in the future, you're going to be creating the project yourself. And so I'm going to show you how you would do that. So you would go File here, and then New Project. And I'm not going to save that R data. And I'm going to create this new project in a new directory. New project, and I'm going to call this directory something sensible. So in this case, because this was my first application exercise, I'm going to call it 01 Apex Penguins. And then I'm going to click Create Project. And so that's going to create the project. So that's the first step that you're going to do every time you come into RStudio Pro for a new lab or a new application exercise. So I just went to File, New Project, and then I named the folder as well as the project itself. So if I go back here and click Home, you'll notice I see a couple other folders. And so these are all ones that I had created previously. And I can get back to the one that I just created by clicking on this 01 Apex application exercise penguins. So the only thing I have in this folder now is this .rproj file, which is basically just this indicator that I've created an R project. And R projects are really nice because basically it holds everything in a self-contained single spot, so I can work with it a little bit easier when I'm using R Markdown, which we're going to learn a little bit more about in a second. Okay, so that's the first part, is creating that new project. The second step is going to be to upload a starter file. And so this also was already on your RStudio Pro for your penguin example, but for your lab, it's not going to be there. So I'm going to show you how I would do that. So over here in the Files pane, I'm going to go ahead and click Upload, and I'm going to choose a file to upload. And so I'm going to go to my Downloads, and I'm going to find the file of interest. And actually, because this is I'm going to actually pick this 01 Welcomes Penguin RMD file here. And I'm going to go ahead and upload it. So that's just going to be wherever you had downloaded that file. And you're going to get that starter file from Canvas. I'm going to show you that when we get to that step a little bit later. But that's how you upload it. So first we create a new project, and then we upload our RMD file into the project. So we get that from wherever we had saved it locally on our computer. And then we click on it to open. Okay, so this is probably where you started last week because the file was already there and the project was already created. So the first thing I'm going to do is I'm just going to knit this file. And so to do that, I'm going to click this knit button here. And it's going to go ahead and knit it for me. And so now I see in this output window my knit HTML file. And so this is really nice. It's a nice rendered file. You'll notice it's a little bit cleaner than the .rmd file looks. And it ran my code such that it created these nice plots for me. And I also have this nice appendix here with the full data set. All right, so I'm going to edit this plot down here a little bit. So instead of looking at the flipper length and the bill length, I'm going to look at the flipper length and the bill depth. And so first, let's go back and knit that file to figure out what variable name I'm going to need to be able to do that. So here at the bottom of this file, I have an appendix that has my full data set. And right now I'm looking at bill length and flipper length. And instead I want to look at flipper length and bill depth. And so this looks like the variable that I'm going to be interested in, bill_depth_mm. And so I'm going to swap out this flipper length, or this bill length rather, with bill depth. Okay, so that's the first part. Oh, when I tried to run it, it didn't work, and that's because it said it couldn't find the function ggplot. Now that was because I actually didn't run locally my libraries before running this code chunk. So if you'll notice, it worked when I knit, and that's because when you knit, it runs your chunks in order all the way down. But when you're running things locally, you have to make sure that you run them in the right order before you are able to see a subsequent chunk. So when I tried to run this before running the code up here, it didn't work. So I needed to make sure to do that. And so now you'll see this was my error because I hadn't loaded my packages. And so by clicking this green arrow up here in load packages, it loaded the 3 packages, and then I could click this green arrow and run this. Okay, so here's my plot. If I knit my whole document, I can see it maybe a little bit clearer. And I'm not quite finished with my task yet. So you'll notice this plot does look different, but all of my captions now are incorrect. So this still says flipper and bill length, even though it's flipper length and bill depth. And you'll notice my y-axis here still says bill length, even though it's in fact bill depth. So let's update that now too. So we're going to change this to say flipper length and bill depth. And then we're going to change this to say bill depth. So now let's knit that one more time. Great. So now our plot matches what the task at hand, what we actually did. You'll notice I have 2 warnings: removed 2 rows containing non-finite values, and then removed 2 rows containing missing values. So these are related to the same 2 values. There were 2 values that were missing in this data set, and those were removed prior to creating this plot. It's really important to pay attention to those warnings because you want to make sure that you understand what's happening with your data. If we were doing a more complete data analysis, and as we move through the course, we definitely will be, you would explicitly either remove these values yourself or explain kind of what you wanted to do with those along the way. Okay, so now I have my final knit document, and you'll notice I've got this new file over here, welcomepenguins.html. And so what happened was my welcomepenguins.rmd, when I knit it, it created this welcomepenguins.html. And this file here, this welcomepenguins.html, that's the file that you're going to want to turn in on Canvas. And so the final step here is going to be to download this file. And so you're going to want to click this checkbox and then click export, and then pick the name you'd like to give it. I usually like to just keep it the same, and then click download, and it will download it for you so that you can then upload it to Canvas. And so that's that. That is the finished the demo for this penguins data set. I think this is particularly a nice way to demonstrate the utility of RStudio and particularly using .rmd files. Because you'll notice here, each time I knit my document, I was able to make a change and it updated everything accordingly, which is exactly what these R Markdown documents are great for that kind of reproducible research that makes for very good analyses. All right. So recap, what did we do? So I created a project in RStudio. I uploaded my .rmd file into RStudio. I ran my analysis using R Markdown, and then I made an edit to the analysis, and so I changed my y-axis there. Instead of looking at bill length, we looked at bill depth, and then I reran my analysis using R Markdown, and it recreated my figure accordingly. So what did we do this with? We did this with R and RStudio. And so our scriptability here was with R. So that's basically the scripting language, the statistical language that we used. And then the literate programming, which was the code, the narrative, the output in one place, that was with R Markdown. So what is R in RStudio? R is a statistical programming language, and RStudio is a convenient interface for R. A fancy word, so sometimes people call it an IDE, which is an integrated development environment. And so at its simplest, this comes from a book called Modern Dive, and I really like this analogy. They say R is like the car's engine, RStudio is like a car's dashboard. So basically, we're using R, that's the main driver that we're using. R is in the back end, and RStudio is basically just a nice interface that allows us to do things in R. So let's take a tour of R in RStudio. I'm going to tell you a little bit about the console, using R as a calculator, environments, loading and viewing a data frame, accessing a variable in a data frame, and R functions. So let's go back to our RStudio workspace and pull up that session here. So I'm going to go ahead and close this RMD file, and I'm going to clear out this console so we can just kind of start from scratch here. So the first thing I want to show you is basically just how you can use your console. So in RStudio, when you get to RStudio, the top thing you're going to see is your RMD file if you have one. So let's just reopen it so you can kind of see the layout. You're going to have your main file, and then underneath down here you're going to have your console. And your console is going to be where you're actually running R code. Your RMD file is basically the static place where you're holding everything that you want to be in your final report. And then over here on the right, you've got a couple tabs here, the most important one being the environment. We'll talk about what that is in a second. And then underneath, you've got more tabs, and the two that we're going to be most focused on here are files and plots. And the files we've already talked about a little bit. We've talked about how to upload files. We've talked about how to export files, clicking on this More button. And we've talked about how to open files by clicking on them. For example, when I clicked on this .rmd, it opened the file. Okay, so down here in the console, this is where you can run functions or operations in R. So for example, I can use R like a calculator. So I'm going to demonstrate that. I can do something like 2 plus 2, and it will tell me it's 4. And so that is kind of the basic functionality in R. Another thing we can do from the console is we can learn about functions. For example, using the question mark, we can access some help data. So if I do question mark mean, it's going to tell me about the function mean, which is an arithmetic mean. And it also tells me about the arguments for that function and what they actually are. So the first argument is going to be an R object, and then there's some additional arguments that I can give. So for example, if I wanted to take the average of 2 and 3, I could do it using the calculator version. So I can just do 2 plus 3 divided by 2. It'll tell me 2.5. Or I can do the mean of 2 and 3, and it'll tell me 2.5. So that's using functions and kind of the calculator version of R. The next part is the environment. So you can save objects in R. For example, if I wanted to save the object X, I can use this assignment variable, and I can save it as 2. And you'll notice up here we've got X, and it's assigned the value 2. So if I type X again in my console, it'll print 2 to indicate that that's what's in there. And I can use these objects the same I could as if they were just numbers themselves. So for example, X plus X is going to give us 4. If I saved Y as 3, I could do the same thing I did before. I can do X plus Y divided by 2. And I can also do the mean of X and Y. So you'll notice all of these are getting saved here as values. So these are individual values. You can also have data sets in your environment. For example, when we had the Palmer penguins package loaded, so let me go ahead and load that, library Palmer penguins. I could look at the penguins data set by running it in my console. And so this is going to print the data set here, and it shows me each of these columns. I can access a single column by using the $sign. For example, if I wanted to pull out the bill length, I could do this, and it'll pull out just those values. And I could save this as a new object. So if I wanted to call this new data, and I wanted it to be my penguins data, You'll notice up here in my environment, I've got this object called new data. And now when I run it, it's exactly the same as penguins because it was assigned to be the same. All right, so we've covered how to use R as a calculator. We've covered functions. We've covered data sets. This is the main way we're going to be using data sets in this class at the moment, data sets that are included in packages. As the class goes on, I'm going to show you how to load data from a file, like a CSV file, for example, but we're not going to do that for a little bit. And we've also covered how to access help files. We've covered kind of how to navigate this RStudio window here. So I think that's everything we were going to cover. Let's see, console, using R as a calculator, environment, loading and viewing a data frame, accessing a variable, and R functions. Yep, we've got it. All right, so R essentials. Here's just a short list of kind of the big picture that you need to know about R. Functions are most often verbs, and they're followed by what they will be applied to in parentheses. So basically, do this to this. This is going to be a function, and this is the thing that you're doing the function to. Or you could have multiple things. So you could be doing this to that with those. Columns can be accessed in variable names in data frames with the $sign. So you'll do data frame, $, variable name. So we did that with the penguins data just now. We accessed that bill lengths variable. And packages can be installed with the install.packages function and loaded with the library function. And you'll do this loading once per session, and installing only needs to happen once ever in an RStudio Pro instance. And in fact, most of the packages that we're going to be using in this class, I will have pre-installed for you on the server, so you won't have to worry about that. Now, if you're not using the RStudio Pro server, if you're using RStudio on your personal computer, then you will need to install all of the packages yourself. So to install packages, you do install.packages and then the name of the package in quotation marks. And to load the package, you use the library function. So the tidyverse is an opinionated collection of R packages designed for data analysis and data science. And we're going to be using this suite of packages a lot for doing data analysis. All of the packages here, they share an underlying philosophy and a common grammar. And so they are nice in that regard. And so we're going to be focusing a lot on this suite of packages. And similarly, there's the tidymodels suite of packages. This is an opinionated collection of R packages that's specific to modeling and statistical analyses. And again, these share an underlying common philosophy and grammar. And so we're going to be using tidymodels functions as well. Okay, let's talk about R Markdown now. So what's good about R Markdown? So R Markdown basically allows you to create fully reproducible reports. Each time you knit the analysis, it's run from the beginning as if you just opened your R session from scratch and ran it from top down. So that's great for reproducibility. The other thing that's nice about it is it's simple Markdown syntax for text. Your code goes into chunks, which are defined by 3 backticks, and then your narrative goes outside of the chunks. The other thing that's nice in R Markdown is that you can do math mode, which you contain in $signs. And that's great because it gives you kind of the ability to incorporate high-level kind of LaTeX-like mathematics in your reports, should that be necessary. So let's take a tour of R Markdown. We've already, in my intro, I showed you this a little bit, but I'm going to basically show you in more detail knitting documents, R Markdown, and some R syntax and math mode. So let's go back to our RStudio session. I'm going to create a brand new R Markdown file here. So I'm going to call this demo. And so this top part of your R Markdown document, this is called the YAML. And this is where you can put some parameters, for example, your name as the author, and the title, and the output type that you would like. For now, we're going to be using HTML documents, but in the future, we might switch this, for example, to a PDF document. So you'll notice here, we've got to indicate a section heading, we use the hashtag. And in fact, so a single hashtag is going to be the largest title, a double hashtag will be a slightly smaller title, a triple hashtag will be a little bit smaller than that, and so on. So I'm going to delete all of this so that we can just go from scratch. I'm going to do, let's see, this is going to be a section, and this is going to be a subsection, and this is going to be a subsection. So let's just knit that. I'm going to save this as demo. And let's see what that looks like. So here it's got my title demo. It has my author name, Lucy D'Agostino McGowan. And then you'll notice I have 3 different sized sections. The biggest one because I used 2 hashtags. The next one is a little bit smaller because I used 3. And the next is even smaller because I used 4. So we can have sections and subsections like this. The next thing we can do is have regular text. For example, here is some text describing my analysis. I did 1 thing, 2 things, 3 things. And so what I'm showing you here is that you can do things like include bulleted lists, and you can also do things like bolding your text by surrounding it in 2 stars, and you can italicize by surrounding in underscores. So this is basic Markdown syntax, which is nice for being able to basically write out something that's going to look pretty formal in an easy text readable manner. Okay, so now let's get to the part that makes R Markdown really remarkable, and that's the fact that we can integrate R code in. And so to do that, we're going to use 3 backticks, a curly bracket, and then the letter R. And we're going to close off that chunk with 3 more backticks. And so this is an R chunk, and this is basically where you're going to stick your R code. A good practice is to label these chunks, and so you put a space after the letter R and then a label. So for example, if I wanted to load packages, I might call this chunk load packages. And so I'm going to load the Palmer Penguins package as an example. And then I'm going to print that package, print that Penguins data set. Penguins data. Let's knit that. All right, so now we can see I've got my big section. I've got some bold text. I've got some italicized text. I have a nice bulleted list, and I've got my R code. First, my library, and then I wanted to print the Penguins data, and it gets printed right below like this. And then I've got my subsections and my subsection down here. So I'm going to change this title. Instead of saying subsection, I'm going to call this math mode. And I'm going to demonstrate how you can do math mode. So math mode is you indicate in an R Markdown document that you'd like to do some math by doing the $sign. So $2, anything contained inside $2 is going to be an equation. It's going to get rendered as an equation. So for example, if I'd like to set the equation y equals beta 0 plus beta 1 x plus epsilon, I can do it like this, and I put it in these $signs, and when I click knit, it will render it. And so when I do a single $sign like this on either side, it's going to be what's called inline, which means it kind of just goes like this. So let's demonstrate what that means. This is inline. Here is my equation. So when I knit this, what I mean by inline is that if I have text around it, it basically gets printed in line with that text. So you'll see now instead of having those symbols, it actually prints the nice math mode here. Now the other thing you might want to do is have an equation that's offset, so not inline, and to do that you can create basically an equation chunk, and I do that by having $signs at the top and bottom instead of just 1. And so for that I'm going to say y equals beta 0 plus beta 1x plus epsilon. And now this equation is going to end up being centered instead of inline. And so when I knit this, I end up with a nice centered equation like that. So those are the main pieces of R and R Markdown. One thing I want to mention, which came up a little bit before, is that when you run something in R Markdown, if you want it to be, so there's two kind of issues here. The first is that anything that you run locally, you need to run in the correct order. So for example, if I restart my R session, and I try to just run this here, it's going to say object penguins not found. And that's because I didn't run the library function first. So even though it's in my R Markdown document, if I'm starting a new R session, I have to still run that one at a time. The next thing that's important to remember is that the order in your R Markdown document is important. So if I moved this library call to after I tried to load penguins, I'm going to end up with an error. It doesn't know, it says object penguins not found. It doesn't know what that object is because an R Markdown document, what it does is it runs your code in the order that it sees it in a brand new R session, which is excellent for reproducible research, but you have to be careful to kind of make sure that you're doing things in the order that you intend. All right. So we've gone over knitting documents, R Markdown, and some R syntax and math mode. Where can you get some help? So the R Markdown cheat sheet is great. This is a really nice way to be able to access kind of all the different pieces that we went through and even more. And you can get to this from R by clicking Help and then Markdown Quick Reference. And that will give you a lot of the details that I went through as well. If you're interested in some math mode help, if you go to the slides, you can click on a cheat sheet here, but the main pieces are in these two pictures that basically show you the Greek letters along with the LaTeX symbol, the word that you would need, that you would use to indicate that you'd like to use that symbol in LaTeX, and then over here some other math pieces, like for example, if you want to have fractions, square roots, sums, products, etc. So this is something, again, that I want to mention. Remember this and expect it to bite you a few times as you're learning to work in R Markdown. The workspace of your R Markdown document is separate from the console. So if I run this in the console, if I assign 2 to X and then I do X times 3, looks good. But if I add a chunk to my R Markdown document, X times 3, without defining X, I'm going to get an error. And why is that? Because those two things are separate. The way that R Markdown works is it basically starts from scratch and runs your code from top to bottom. So if you haven't explicitly defined X in your R Markdown document, even if it's defined in the console, it's not going to work. So how are we going to use R Markdown? Every assignment, report, and project is an R Markdown document. You'll always have a template R Markdown document to start with, and the amount of scaffolding in that template is going to decrease over time. So those templates you're going to download from Canvas for every application exercise or lab, and then you'll upload them into your RStudio Pro instance, and then you'll download the final HTML file and upload that to Canvas. So for turning in assignments, again, each lab is going to have one of these starter files on Canvas. You're going to download this at the beginning of lab and then upload it to RStudio Pro to help you get started. And then after completing your lab, you're going to download the HTML file from RStudio Pro and upload this file to Canvas. Let me just show you one more time how you do those pieces. So the first piece is uploading a file. And so to do that, you're going to click on Files, and then you're going to click Upload. And you'll choose the file from your desktop, wherever you saved it from Canvas, and it will upload it into your project. So that's how you're going to upload the starter file. The next important piece is that when you finish, you need to download the HTML file. I have two here because I have both the one that I did for my Welcome Penguins demonstration and for my demo.html. I'm going to show you the demo one, so let's say I wanted to upload that to Canvas. I would click on it so that I get a checkbox, and then I will click Export, and I'll name it something, and then click Download. That will save to my Downloads folder, and then I can upload it to Canvas after. All right, so go ahead and get started on your lab, and it'll be due in at the next class period at 5 p.m.